Now, floor is for Oliver Knodel from HZDR. Close this.
Okay, so thanks, Majid. My name is Oliver Knoll. I'm from the Helmholtz Center at Western-Rossendorf. And today I will talk a little bit about the next steps on our data chaos, on our data patchwork. Because in the end, okay. Yeah, so the outline for the talk today is, first I will introduce our research center. The problem we have is that we have not only 1 or 2 or 30 beamlines, we have completely different experiments, completely different areas, so our research fields are energy, health and matter. Then I will introduce our data management ecosystem, also the strategy we tried to move forward to support better our scientists. And later on in the end, I will talk about the patchwork, how we bring everything together from the data and metadata perspective. So first, a few words on our center. We are at the end 1,500 scientists, and half of them are scientists. We are member of the Helmholtz Association of German Research Centers, and we have so many different but very beautiful large-scale experiments. So we have the Elbe Center for high-power radiation sources. There we have an electron accelerator, 3 electron lasers, terahertz source, and so on. These are more or less structured experiments where we have more or less access to the scientists and so on, to the detectors, to the data. So similar like synchrotrons and radiation sources. We have also the Dresden High Magnetic Field Laboratory, wonderful experiment, largest magnetic fields in Europe, but completely different kinds of data and metadata. We have also an ion beam center, more structured experiments. We have the Dresden Sodium Facility for Dynamo experiments, wonderful experiment where we rotate liquid sodium in every direction. So strange experiment, wonderful data. And we have the Rossendorf beamline at ESRF, so also an experiment which is located here in Grenoble. So now our ecosystem and the strategy and how we move forward. So our group is the Data Management and HPC group, and we try to support all of these different kinds of experiments with electronic lab books, interactive analysis, publication repositories, and so on, workflow managements, and also PIDs for specific things. So in theory, we collect the data or help collecting the data, then we document everything or help documenting, provide the systems to document everything, then we process the data, analyze, and later on we have the real software and data publication repository. So this is typically our full line. And yeah, we try to make it more efficient. From the real experiment, from the detector, to the final data publication. In a perfect world, it is completely automated, and the scientist here only has to say, okay, I want to publish that. That is the idea in the end. But how it starts? Typically, our experiments are from somewhere here above, so from 2015, 14. Then later on, when the experiments were established, we started with the scientific computing department at HZDR and tried to support these established experiments. So not always an easy job, but that's now our job. We started then also with a data policy, one of the data policies of the Helmholtz Association, where it was more or less clear that every data taken at HZDR should stay at HZDR and should be published open access. That was the idea, but then it was an idea. We need also a data repository. So we established a simple data repository with standard metadata based on DataCite, because we have so many different communities, so a standard set of metadata is not really possible for us. That is in the end the reason why this talk before was wonderful, because we have now Scikit to extend our data repository, because that is the main problem. This repository is in place and it will stay there forever. Now we are working on a RDM landscape to build more or less a life cycle for all our experiments together with our scientists so that we can streamline everything, bring them all in our loop. Then we established the data management catalog, and now we are working on a real data management strategy to write down what the roadmap is in the end. Together with our scientists, this is always important to say. So our data management policy was, or our data policy from 2018, it was the legitimization of publication, handling and deletion of data generated at HDR, and more or less a legal framework for our data management, and in the end, also the motivation for us to further develop data management services together with our scientists. That is in the end the important step when I try to sell the policy to our scientists. This is our data publication system, Rodare. It looks similar to the Knodel because it's the same source code in the end. We can search here also, an index is Elasticsearch at the moment, and we can search for everything inside here, so on title, authors, and the abstract. It's powered by Invenio at the moment. The next step is to move from Invenio to Invenio RDM. Knodel has done that, I think last year, this year, and we are hopefully next year. Our data can be harvested or is harvested by B2Find, so it is findable also on the EU level. And that is important for us to have a repository which is really findable and also data sets which are really findable. So the repository is registered in the registration of research data repositories, also a very important step. And in the end, when we look here, this is a record, we have a preview, we have standard set of metadata, but all this metadata is only data side. So no experiment-specific things. We cannot even search in that. You can upload here in the files, you can upload a JSON file where you specified your metadata, but you cannot really search on it. You can download it and then search inside, but that is a process that's not so nice. So we need here something in addition. So everything is harvested. In the end, when we add here a data publication, we also mint a DOI, and here we see in the end the metadata set is oriented on data side, and that is more or less a problem for us to make it really findable and usable. The data is in the end on our file systems, but everybody can download, for instance, all which is here because this record is open access. The data is harvested via B2Find. This was one of our last projects. The idea was to bring our large-scale research facilities to Rodare, to the metadata. But the metadata is data side, so it was not so easy in this system based on Invenio to add a simple additional field. So we tried here to add just a community, because in the search, the Elasticsearch index is also over the communities. So now it is easy to say, I want all records from Carbosola. And then we have all records from Carbosola. But most of the people don't even know that. So we added also on the front page a simple list of all our large-scale experiments to make them more visible. That was a work of maybe a few hours. But the result is nice because now we can also filter on the metadata and so on and count the data sets of our experiments. That's a nice to have. And the slide's a little bit problematic, so I go over it, it's better. When we look at FAIR, findable, accessible, interoperable, reusable, this is a self-assessment of Rodare. Yes, we have persistent identifiers, we have more or less rich metadata. It depends also on the scientist adding the record to Rodare. So accessible is easy because we have standard protocols, they are open, metadata is more or less always available, 99.9%. And authentication is only necessary when we request access for a specific closed access record. So that is completely accessible. We are also interoperable because we use FAIR vocabularies. Not so experiment specific, but I said it before, it's a little bit difficult for our different, really extremely different communities. But we can also link additional metadata. In the end, hopefully everything is reusable. we have a license, that's very important, and on the rest we are working. But now, few words on our research data lifecycle. Typically, our experiments start with data, with an idea. The data, or the metadata we need also later on for the publication comes also from our proposal management system. Then there's an experimental cycle where we have also documentation inside. So there we have different rounds. Important here is the curate step, where the metadata is curated, updated, and so on, so that we have in the end, hopefully, a very rich set of metadata. And then comes a nice preserve and archive step, followed by a data publication step. And that is this part with Rodare. And later on, that is the thing, when the data is published, it is searchable and it can be reused for next experiments, the insights of previous experiments. And that is an important thing. On one of my first slides, there was this circle in a straight line. We start with an idea and end with a publication. But in the end, the publication is the baseline for a new scientific project. And that is important to say. It's important to say, I think not for you, but for our scientists, to say that it is important to publish the data set and the software. Oh, wrong direction, sorry. So our current state is we have the data side metadata. Desired state is in the end we want to add community-specific metadata. So there is a gap. We need an approach to bring the things together to add community-specific metadata for records. The plan is to integrate Scikit somewhere in between Rodare and the real experiment. Simple idea, but a little bit difficult. Simple idea because we have Rodare, we have a Scikit instance, but how we can bring them together. So this is a nice picture to explain it a little bit. We have Rodare. In Rodare, we have all data sets, but it is necessary from the scientist to say, I really want to publish this data set, this set of data, because it is meaningful and because it is necessary to show these data for a scientific publication. That is important for us here in this case. But we want also to use Scikit in an automated process to register their metadata from really every experiment from our beamlines in an automated way. But that does not mean that every Scikit record in our use case here has a Rodare record. There are only a few Scikit records with an additional record in Rodare. And that is here very, very important for us. Because in Rodare, it is a real publication, so everything has a DOI. But here, every single DOI, it is a little bit difficult with our head of our department because a DOI is expensive. Not so expensive, but for every single data set, automated generated. It's not a good idea. So years ago, we bought a license for the handle server. So we have a local handle server at HZDR. It is globally resolvable, and we can give handles to every digital object at HZDR. That is nice. So it is completely fair. And in the end, for the real data publication, we mint the DOI. And in the end, it looks like this. We have metadata from the experiment. We have different applications where it is easier to curate the metadata. This application is also part of our Daphne for NFDI project. The ideas in the end, the problem is this is completely private. This is in our internal network, so we cannot show these wonderful metadata to the outside world, but we want to show it. Rodare is accessible from outside. That is easy. There's a data set in the end. It is registered in OIDAT, but we need something in between, and the solution for us is here Scikit. We can bring the metadata from the subsystems in an automated way to Scikit, and then when there is a record in Rodare, a data publication, we can reference the data publication directly from Scikit, and everything is fine. But we have in the end two systems to search in and to find something, hopefully. And an important step for me is, I was in the Expanse project, so we also want to provide the Panosk search portal to be part of the Panos data portal in the future, hopefully, maybe next year. And a very important thing is, we also have here, we have seen here the curation systems to work with the metadata, but we have also experiments, beamlines, where the idea is to bring the data in a fully automated process directly to SciCat. We have a talk on that later after lunch, so also focus on a laser experiment at HZDR, and we will see what happens there. So I'm at the end. With Rodare, we have a data publication repository, but only bibliographic metadata. We need something more, and that is in our use case. For our use cases, typically SciCat. For collection, annotate, publication, and findability, SciCat, Rodare, OIDAT, and current step, Panos data portal. And that's everything I want to say today. So thank you.
Thanks, Oliver, for this wonderful presentation. Room for one question.
Thank you very much for these insights. When you mentioned that your management said DOIs are expensive, did you consider other persistent identifier schemes? For example, there is an ARC network that arguably has more tenfold more identifiers than DOI is, and if you set up your own server, then you don't pay, you pay just for the server.
Yeah, good question. So in the end, we started, I think, in 2019 with our Knodel server, and that is now the way to go for us. I think we paid for the registration on Knodel.net $100 or $200 for 2 years, or maybe less or more, I don't know. But that was the way in the past to go for us, and maybe we will change the system in the future. But no real decisions taken at the moment. Only this problem with our DOIs that they are too expensive, but in the end they are not expensive for us. In the end we have, I think, total 300 DOIs for free every year, and we at the moment at maybe 250, 60. But we will see what happens there in the future.
And the first system, I didn't understand the word which you said.
Knodel.net. Knodel.net. That is in the end the service also DOIs are based on. Okay.
Thanks again, Oliver.